Hi, it's me, Joe the Coding Maniac, and in today's video I'll show you how to do text classification with Python, scikit-learn, pandas and NLTK-lib. Text classifications is rather useful for things like predicting whether an email is spam or to what category a text belongs in general. In today's video we'll try to come up with a model to predict star ratings of reviews. So what we'll be doing is basically we try to come up with a model that will tell us the star rating for a review that we will put in. So without further ado, let's see how this is done and let's dive into the code.
Today's tutorial will be a bit different than usual because I currently don't have a second monitor in my setup, so I will show you the code right away and explain it step by step so that you guys will be able to follow along. So let's have a look at the code, right? Alright, first here are the imports that we'll be using throughout this tutorial. We'll include JSON for parsing our text data into a JSON object before loading it into our data frame. We will use pandas for the data frames, use regular expressions, NumPy for matrix stuff, NLTK-lib for text preprocessing, and then a whole bunch of scikit-learn libraries to build our model and for other nice things. Let's start with the actual code. So this few lines will load our actual data set. This data set is provided by Yelp for some kind of contest and consists of around 1.5 million reviews with star ratings and text. We will use actually those two attributes out of, there are so many more, but we don't care about them right now. So we will use the text out of this data set as well as the star ratings. We actually have to do some minor transformation. We need to add these brackets around the whole text to make it a valid JSON array, so that we are able to parse it and to fill our data frame with it. So with this out of the way, we now have our data loaded in our JSON object, and we will fill our pandas data frame now with this JSON data. After this step, we have a pandas data frame to work with. A pandas data frame is a container for the data set that is very convenient to work with, as you guys will see soon. And now we instantiate a stemmer class or a stemmer object. What a stemmer does is basically it tries to be smart and convert words to their root. So basically, if there is the word went text corpus, it will try to come up with some smart logic to make go out of it. And if it can't do this, it basically just cuts the last character of the word and leaves the word this way. The next thing is we will get a list of stop words. Stop words are words that aren't really useful or that don't matter that much and are very common, like and. We have those two things imported from NLTK-lib, and with this done, we can do the actual data preparation. So how does this look like? Basically all and everything happens in this one line of code. And this line looks rather complicated, but in reality it isn't that bad or that complicated. So now let's go through this step by step and see what's going on. So the third thing is we will use our pandas data frame, and specifically the column called text, in which all the text of the reviews is included. So basically this data frame has 1.5 million rows, and each of those rows has a text column. So we will use this text column and call the apply method. And this apply method will apply this lambda that is coming now to every text column of those 1.5 million rows. And what does this lambda do? So first of all, we use our regular expression to replace every character that is not a letter by a blank. So we strip all the numbers and punctuation and everything that is not a letter from the text and replace it by a blank. After this, we split the text, which results in a list that contains just the words that are left. And after this, we use a for comprehension to get every word out of this list and use the stemmer to stem this word, but only if this word is not contained in this list of stop words, because we don't care about them. After this, we join everything back together by blanks, so we get the words separated by blanks in a string. And after this, we actually also call the lower method on the string so that the whole string is now lowercase. And with all this done, we assign it to a new column which we call cleaned in our data frame. So our data frame has now one column more than it had before. So this cleaned column now contains the content of the text column after it has been processed by our logic. In the next line, we basically make our training and test splits. So we use 20% of our data set for test data and the remaining 80% for our training data. We use the data frame and specifically the column that we just created, the cleaned column, as our features, and we use the stars column of the data frame as our target vector. After this is done, we now will build our actual model. Our model consists of 3 steps, as you guys see. First, there is the TF-IDF vectorizer, which basically takes the features and creates a gigantic matrix, which is called a bag of words, that consists basically of the word counts of every single word. And the TF-IDF part is term frequency inverse document frequency. And what this does is actually pretty smart. This TF-IDF algorithm gives every word a certain weight, and every word that is more common, so every word that appears in many of the different documents or reviews in our case, will get a very low weight, and words that don't occur that often will get a higher rating because they are more relevant. So words that appear like very often, like and, the, will get a very low rating because they aren't very relevant for training our model. And words like awesome, good will get a higher rating because those words are actually relevant for us. So this class performs actually 2 things in one class. There are actually separate classes for bag of words and for the TF-IDF stuffs. Those classes are called count vectorizer and TF-IDF transformer, but we will use this combined class so that both steps are done and we just have to call one thing. Really nice, isn't it? Alright, now let's talk about the parameters that we are going to use here. An n-gram range basically tells our algorithm how many words to consider. So if using this n-gram range 1, 1, the algorithm would consider every single word as a separate feature, which is basically the default for this parameter. We will use 1, 2, which tells it to have a look at every separate word, but also to have a look at a pair of 2 words. What this will enable us is in a text that is like, the meal was not so good. The algorithm that considers every single word would probably tell us, okay, this is a good review because the word good is in it. But the algorithm that considers 2 words will see, oh, there's a not good, and so would tell us probably this isn't a good review, this review is actually rather bad. So we will use the n-gram range of 1 and 2 to prevent stuff like this from happening. Also, we tell our algorithm that our stop words are English, so it will also filter them out. And also we tell it to use a sublinear TF function, so the TF-IDF algorithm thingy will use a logarithmic function, and yeah, it performs better. I did a few tests, so we just use this one. The next thing is, out of this whole bag of words, this gigantic matrix that is calculated by the vectorizer, we now are selecting the best features to train our model. So basically we say we want to select the best 10,000 features out of this gigantic matrix with over 1 million features and use the chi-squared algorithm for this. So the chi-squared algorithm is a stochastic thing that calculates the dependence of features, and also gives weightings so that features that are very dependent on each other aren't that high in the weights, so that those get lower ratings and are not that relevant, so that we only get good features for our model. And the last thing is the classifier. We will use this linear SVC algorithm. I as well tested a lot of different algorithms, and this one performed the best on our use case here. We will use the lasso penalty. I also did a lot of tests on this one, and the lasso performed better than the ridge regression algorithm and the ElasticNet algorithm. If you want to know more about feature tuning, I already have a video about this, so click here and check this out. The next parameter is the maximal number of iterations to use for this algorithm. So we will set this to 3000. And we need to set dual to false, because otherwise we won't be able to use the lasso penalty. With this done, our model is built. So now we have a model, but now we have to train it with our training data. This happens in the next line. We will fit our model to our training data, as you guys see. And what I didn't tell you is what this pipeline class actually does. So as the name says, it builds a pipeline. So with the fit method call, we give it the training data as a parameter, and what happens now is this data is passed first into the TF-IDF vectorizer. The result of this one is passed into the select kbest, and the result of this one is passed into our classifier, and then our model is done. So this pipeline is just a convenient way of writing all those separate things without using temporary variables and stuff like that. So it's basically a convenient method. With the fitting done, we now have an actual model that we can use for predictions. So now the model part is done. Now we can use it and have fun with it. The other lines of code here are just some preparations of outputting of different stuff here that I want to show you, and yeah, let's go quickly through it. So basically here I get the instances that were created during this pipeline process, so that I can use them here in the outputs. Yeah, this is just some preparations, it doesn't even matter. And what this will print is the best 10 keywords for every class that we have. So we have a star ratings from 1 to 5. So this will print the best 10 keywords for rating of 1, the best 10 keywords for the rating of 2, and the best 10 keywords for the rating of 3, 4, and 5. The next line here is the accuracy score, so that we will see how good our model actually predicts the values. And this now is the text that I typed in, and we will see what our model thinks, what star rating this text should get. So basically that's it for the code. Now let's run it. This will now take about, I don't know, maybe 5 to 10 minutes on my laptop, which is the latest MacBook Pro. The times may vary on your machines, so just grab a cup of coffee and we'll see soon what our model thinks. Alright guys, here are the results. So as you guys see, here are the top 10 keywords for every rating. For rating 1 there are things like 0, worst, horrible, and for 5-star rating there are things like rock, amazing, good, best. So it makes sense, right? Our model has an accuracy score of 58%, which at first doesn't sound that much, but you guys have to think those aren't texts that are category specific, like texts about I don't know, car racing and soccer. You can distinguish those two categories much better than star ratings. So star rating of 5 is pretty similar. A star rating of 5 is pretty similar to a star rating of maybe 4, and as well a star rating of 3 could as well be also a star rating of 2 or a 4. So it isn't that exact, like really categorizing other types of text. So it makes sense that the accuracy score rating is a bit lower than usual. But I typed in a text and this text was, "That was an awesome place, great food." And our model thinks it is a 5-star rating. And guess what? I would also think so. So our model isn't that bad after all. And with this is the end of the tutorial. I hope you guys enjoyed it. If so, please subscribe to my YouTube channel. Please follow me on Facebook to get updated as soon as new content is available. So thank you for your time and see you the next time.